Now we're going to start a new topic, which is indices, and indices, of course, is just another word for powers. It's the fancy word for powers. So one index, two indices, and we're going to start by going over laws of indices. The first three laws, you've actually used them before, even though you possibly don't realize that you have. So the first law of indices that we need to remember and that we need to learn is, it's written in our log tables, and it's written as this. If I have a to the power of p and I multiply it by a to the power of q, then that is a to the power of p plus q. So that looks really confusing when you see it in your log tables. So let's put some words on it. And the words we put on it is that when you multiply two powers, when you multiply two numbers with a power, two powers, you add them. So that's kind of a shorthand way of writing it. Now, there's a couple of things that are really important about this. First of all, when I have a number to a power, we have a special name for the parts of it. This number here is called the base. So that's the base, is the big number, the one that we're raising to a power, and the power that we actually raise it to is called an index. So bases and indices. One index, like I said, and the plural is indices. So that's really important. When I want to multiply two powers like this is only true when the base numbers are the same. So this is only true when the base numbers are the same. So for example, if we look at an example of this, if I have 3 to the power of 2 multiplied by 3 to the power of 7, that's not 3 to the power of 14, it's 3 to the power of 2 plus 7, it's 3 to the power of 9. So that's what I'm talking about, adding the powers like this. However, if I had 5 to the power of 2 by 3 to the power of 2, I can't do anything with this. Okay, I have to work them out. We can't use our law here because the base numbers are different. I could go and say, well, that's 25 by 9 because I can square them. The base numbers are different. I'd have to just square out the numbers and then multiply them together. I have no law of indices that works there. This works with x's as well, and x's is where you've seen it a lot. So if I've got x squared multiplied by x to the power of 3, that's not x to the power of 6, that is x to the power of 2 plus 3, it's x to the power of 5. And you've seen that in algebra quite a bit. Okay, so that's the first law of indices, which you have used before without ever writing down that it's a law. The second law of indices is kind of the same thing, but for division. So when I have a to the power of p divided by a to the power of q, then I can write that as a to the power of p minus q. Or when I multiply, or when I divide two powers, I subtract them. When I divide the bases, when you divide two powers, and again, it's important that they have the same base. With the same base, you actually subtract the powers. Okay, so what does that look like with an example? The same note applies as did before. This only works when we have the same base. So for example, if I have 7 to the power of 14 divided by 7 to the power of 2, you might think that's 7 to the power of 7, but it's not. We don't divide them. That's 7 to the power of 14 take 2, which is 7 to the power of 12. It works for letters as well. So if I have x to the power of 10 divided by x to the power of 3, that's x to the power of 10 minus 3. That's x to the power of 7. But of course, if I have two different numbers, if I have 15 to the power of 12 divided by 3 to the power of 3, I have no law for simplifying this because the bases are different. So we just leave it like that, or put it into our calculator if we know the numbers, or if they're just letters, we just leave it like that. Okay, so that's the second power. Second law. The third law, I call this the pow-pow law. So if I have a number to a power, and then I raise the whole thing to a second power, this is when I multiply the powers. So that is a to the power of pq. So if I have a number to a power and then raised to a second power, so it's like a power to the power, and I sometimes just call these a pow-pow because you have a power to the power, then you multiply the powers. Doesn't matter about bases because I only have the one number here. So let's look at an example of this. If I have 3 to the power of 5 all to the power of 2, that is 3 to the power of 10. If I have x to the power of 9 to the power of 3, sometimes it's written like this, that is ambiguous. We need brackets. So is that x to the power of whatever 9 cubed is? We don't know. Okay, we need brackets to make this clear. So x to the power of 9 all to the power of 3 means x to the power of 27. But if I put my brackets differently, x to the power of 9 to the power of 3, like this, means I'd have to get 9 to the power of 3 first, which is 729. So you wouldn't be clear about that. Now you won't get a question like that in your junior cert because they're not trying to confuse you, even though it feels like it sometimes. Okay, so those are the first three rules of indices, and I want to go on to a fourth one, which you probably have heard before, which is that anything to a power of 0 is equal to 1. Anything, any number at all. And I encourage you to pull out your calculators and check that. So anything to a power of 0 is equal to 1. Really? 5 to the power of 0 is equal to 1. 1, 1, 1, 1, 1. Just mash our calculator a little bit. To the power of 0, it's equal to 1. So it doesn't matter what number you put in there, you will get 1 when you raise it to a power. 3 to the power of 0 is 1. 100 million and 47 to the power of 0 is 1. which means even if it's a variable, x to the power of 0 is 1. Minus 18 to the power of 0 is 1. 3.298 to the power of 0 is 1. Any number at all, if you raise it to a power of 0, is 1. Why? Do you need to know? Well, you might like to know. Well, if I have x to the power of 0, where would that come from? When would I end up having x to the power of 0? Well, it might come about because I subtracted two indices like this. I'm kind of working backwards. So if I have 3 take 3, then I've got a power of 0. But that subtraction with indices is the same as division. That's the same as x to the power of 3 over x to the power of 3. And anything divided by itself is 1. So regardless, we could put any number there, 17, 18, 100. What I'm saying is that it's the number take away itself. So it's the number divided by itself, which is why we get 1. Okay, I hope that's clear. There are 9 laws of indices that we need to learn, but we're going to stop there for today. Thank you.